Okay, thank you very much for inviting me to this presentation. I guess I will use around 10 minutes to explain to you what I have been doing since I started here as affiliated. But I will use most of the time to explain to you what I'm doing right now. So this is more or less what I'm promising to you to. So, as Sally has said that I am an economist. So what are the issues that I'm occupied by is about explaining all the factors behind inefficient distribution of resources, but also all problems related to unfair distribution of income and resources among humans. And lately, I have been working in different issues, but lately I have been concerned about studying the effect of climate change on ecosystems and how affects these climate patterns on the economy and how that affects the well-being of humans. So that is my preoccupation in these days. So let me just mention to you some of the work that I have been publishing since 2022. This is my recent publications. And that you see a little bit here comprises very different type of topics, you know, so I guess a little bit different from geography, or especially the physical geographers. Well, not all economists, but some economists spend their life doing also one topic, right? So, but I have been trying to diverse a little bit doing different things. Sometimes it's an issue of where I'm working. I would like to, a year ago, I presented my work related to mining, right? On the effect of health and environment as a result of mining activities. I would like to, because some of the issues here may be a little bit unfamiliar to you. Let me, before I continue, this is my work that I have been publishing. I have two working papers. One is with Salim, is about studying the effect of peace agreements on poverty and GDP and land use. So how these peace agreements improve those elements. And then the one that I'm going to present today is about the special analysis of the effect of climate on economic activity. And the focus is on the US. Okay, so I would like to focus on my previous work very shortly. Why I have been doing these two papers, or maybe three. Okay, so the first one is about carbon emissions from the maritime sector. Okay, so why do I preoccupy by that? Because if you see in this figure, the maritime sector is responsible 51% of the total emission in the world, right? So that caught my attention, what is going on here, right? So, and also because I work on international trade. So then I said, well, trade is causing some issues, some externality, what we call it, right? And we also should know that 90% of the shipping activity is derived from transportation of goods, right? So it's quite a bit of activity transporting goods from one country to another. So I was, then I said, well, which countries are responsible for this trade? You know, which type of goods are the ones that are responsible for emitting this carbon, right? And it's related to the weight, right? The bigger the weight, you know, the heavier the ship, and the more fossil fuel you need to use, right? So this is this is what I'm studying as an economist. I see a problem, and I say, well, why don't we try to find out what is the reason for that, and what could be the policy that can ameliorate this problem, right? So that, and we know that. So this sector, I don't know if you're familiar with carbon taxation. Are you familiar with carbon taxation?
Sorry, are we recording? Oh, is it recording? Oh, yeah.
Yes.
Did she put it on?
Yes, she did that.
I just want to make
She did
sure.
definitely.
It is recording. Yes, you're right. Yeah. Thank you.
Well, for the ones that are not familiar, a tax is like any tax. That you pay tax on your income, right? In this case, it will be a taxation according to the amount of carbon emissions you emit, right? In this case, the shipping sector. But this shipping, not the shipping sector, not the aviation sector, pay any tax on the emission that they emit and the carbon that they emit. So I just want to point out what are the consequences of that. Of course, like anything, the fuel that they use, of course, first of all, is very dirty. You can say that the fuel that the shipping uses is the residual of the gasoline that you use in your car. It's the worst, right? It has been improving a little bit, but it's still it's just a bit. So, of course, when you don't tax this industry, of course, they don't have an incentive to improve the technology, even though they say they are improving. And of course, there will be too much fuel consumption. Like everything is cheap for you. What do? You consume more, right? So you have to experience a little bit of high price to feel the pain, right? So when there is no tax, the fuel is too cheap. So you might as well consume as much as you can, right? So that's the consequences. And what is another important thing that is important for developing countries is that if this industry will pay a little bit of tax, that money can be collected to help developing countries in becoming more green, to implement infrastructure, green infrastructure. So that is the issue, the motivation for me to do this work. So what do I get from this study? The United Nations, the International Maritime Organization, is responsible for having the shipping sector working responsibly, right? Quote unquote responsibly. So they have promised. You go to the web and look for IMO. They have said that by 2030 they will reduce carbon emission by 20% from the level of 2008. And by 2040, they will reduce their emission by 70% for what their levels of 2008. So, but also that implies that they will implement new technology, new shipping, new fuel, hydrogen, and whatever. But they say, but we need resources, right? So they don't have enough money. And say, well, why don't you put some tax so you can collect some money, right? So my work, our work in this space, find that by 2050, and of course, doing some forecasting on how much the technology will improve, even if you put a 40%, $40 per ton of CO2, even with that tax, with new technology, new shipping, new fuel, by 2050, they will be able to reduce 28%. So these promises are just illusory, right? So that is the result of this work. So they need to do something about it. The other thing is that I studied the heaviest product, right? So this is how much carbon emission will be reduced if they impose a $40 tax per ton of CO2. Okay, so ours is very heavy. All these products are very heavy. So these are the ones that are emit most. Okay, so let me go to the next. Another work, I think, the two that I'm going to present, and then the work with Salim. The other work is, did you know that countries, especially developing countries, subsidize fossil fuels? The gasoline and diesel that they pay in, at the gas station is not the real price, so they subsidize. So they pay lower price than the real market price. Okay, so if you account for all the subsidies in the world, and the developed countries also subsidize the petroleum companies, so that is not taken into account. So if you account for all the subsidies in the world, that would account for $697 billion. That's not a very small amount, right? So, and that represents 6.8% of the global GDP per capita, GDP, excuse me, in the world. So that's quite a bit of money. So you can think of how the governments can, if they eliminate these subsidies, protect the poor with some kind of another compensation. When you subsidize fossil fuels, you subsidize both the rich and the poor, right? So you should try to do something for the poor, but not for the rich. And that happens in developing countries. So the question is that it's very contentious policy because they say, oh, you're going to affect the poor, you're going to, the poor is going to be poorer if you take all the subsidies. So, but again, with intentional policy, with target policy, you can alleviate that problem. So, what we did in this work is to have a survey asking people, what do you think about eliminating subsidies? And we have a big questionnaire asking them. And then surprisingly, we found that they are willing to pay more for fossil fuels, right? But they say that they want that money that the government will save in subsidies to be invested in infrastructure, right? So that was the condition. If you want to eliminate subsidies, we have to see that that money is saved, but the government is invested in infrastructure. I think that's a very important result that we got. So let me just jump from for the sake of time. If I have time, I'll come back to this. This is the work with Salim. It's about studying what are the effects of implementing a peace agreement. Once you have a peace agreement, do people get better livelihoods, right? So that is the work that we are in the process of revising it to send it to publication. But we consider the case of Guatemala, which has a experience of war for almost 36 years, right? So, and there was a signed agreement was signed in 1996. But this work is about asking, are these people better off now with the peace agreement? Now, of course, just the peace agreement alone is not the only condition for making this peace agreement successful, right? So you have to have institutions in place to make this peace agreement successful. Okay, so that's what we are working on. So we focus on poverty and GDP and land use. So because these indigenous people were in war because of injustice about land distribution, now they have, our preliminary results indicate that they have more land to work with. But there is a little bit of a problem, perhaps, because there is some kind of deforestation. So the question is whether more land for agriculture, but more deforestation. That is something that we need to be watching for. Okay. So this is what my old work, and I would like now to go into the paper that I'm writing right now. And this is about the effect of temperature and precipitation on GDP, on economic activity. And I'm studying only the case of the United States. So, but this is a special analysis. And I promise you, this is I'm a little bit shocked myself, but this is the first work studying the effect of climate on economic activity using spatial analysis. It has not been done before. It is about what has been done before. What is the effect of temperature on GDP in country X, the average? Or more, what is the effect of temperature or the average effect on the whole world, right? And they use data per country. Okay, so I focus in the US to concentrate on that case, and maybe my work will do for the whole world, or by country perhaps, we'll see. But anyway, so as I mentioned, there is a big literature studying in economics, the effect of climate on economic activity. And basically it's on GDP growth, the gross domestic production, and all the level of GDP. Okay, sometimes it's per capita, production per person, or the total GDP. So, but of course there is a whole range of approaches, especially scope. Scope in the sense that sometimes it's worldwide, sometimes it's just Africa, sometimes it's Latin America. But I haven't seen a concentrated work on the US. I haven't seen that in the way I do it anyway. So, and of course, different type of data and methodology also very different. But I haven't seen the approach that I'm following today. I have done doing this work. And of course, you know, disagreements on which number, because the numbers can be from enormous variation, you know, a whole range of numbers. And that includes Nobel Prize winners, right? So it comes with different numbers that I really don't know how they get that. So another thing that I'm doing is that most of the work is studying the effect of temperature on GDP. Yes. And no, and of course they find a negative effect on GDP, right? But of course, it still has, again, I said, the discussion of which one is the one that we should rely on, you know? And that's important because how do you make policy for the future? You don't know what's the real number. What was the effect of temperature or climate in general on GDP, right? Okay, so one thing also.
Everyone know what GDP is, I would assume, maybe just to define
Yes,
for
maybe I
them,
said,
so we have
okay,
some
so
engineers.
what do we count by GDP is all the production in the whole economy, you know, including, and that includes the national, but also includes all foreigners that produce in the USA, in this case, the US. So what is the GDP in the US? Is all that you can produce in the land, you know, includes foreigners, right? And by GDP per capita, we say this total GDP per person.
So it is goods and services.
Goods and services.
Services too, so all the haircuts and the universities
Yes,
and everything that is
everything,
part of.
your ice cream, you know, anything you can think of, right? Okay, so very few papers on the effect of precipitation on GDP. And that's what I'm trying to do today, okay, among other things. So there is one exception, okay, so and everything is at the national level, right? Country X, country Y, country Z. What is the GDP, the total GDP in the country Y, X, and Z, right? And the same temperature and precipitation for this thing. So the Mania is the exception. He studied both at the national level and at the administrative level one, right? But the problem is that they study what is the question is, what is the effect of temperature and precipitation, the average effect of temperature and precipitation in the whole world, right? So just one number, right? Or two numbers for precipitation and temperature, right? So, and that is a little, for me, you know, these are macroeconomists, and I'm a combination of micro and macroeconomics, and it makes me a little bit uncomfortable to study for the whole world. And so what I'm doing here again, first of all, I'm studying in addition to temperature precipitation and separate, because the combination of precipitation temperatures, I'm sorry that climatologists are not here, but I understood that there is a very complicated relationship between temperature and precipitation, so I hold them separated, right?
No, we have climatologists.
Yeah. I'm sorry, I'm so sorry, yes. So correct me if I'm wrong, okay? Yes, so I'm trying to keep them separated because I am getting myself informed, and it's not it is not a trivial relationship between the two, right? So the other thing is I take into consideration that the economic activity in this county, is affected by the economic activity of the other counties. Number one. Number two, that the temperature in my county, I study this at the county level, is affected by the county and the other counties. So this is the special analysis, which has not been done. I'm amazed that it hasn't been done. So this is the contribution of this work, right? So so I study this work at the initiative level 2, and the data is highly degree of resolution. So the other thing is that I'm very occupied by the spatial time variability. So I don't study just for the whole United States, I will give you an estimate for the whole United States for comparison purposes, but I study the regions, right? So what is the effect of, and of course, I can be still criticized. Why did you study such a whole region? Maybe you can study at the state level, right? What is the effect at the state level, and Delaware, just Delaware. And of course it can be done. Why don't you study just New Jersey and compare New Jersey with Pacific? Or why do you compare Newark with California, things like that, right? So that can become a very big work, right? So that's the way I will expand this work. So also, I don't study, the period of work is from 1990 to 2019. I will expand it to 2022. I was afraid to include 22 because of the COVID. But then I thought there should be no reason to include that because we had the financial crisis in 2008, right? So I should include everything. So, but anyway, so I have to 2009, and I have 3 decades. So the point is that the effects that I find for the whole United States, for the whole period, does it vary depending on the region? Does it vary depends on the period that I consider, right? And yes. So this is so again, what is this spatial modeling? In few words, is to consider that your neighbors affects you, right? And everything that is playing a variable, in this case GDP, like temperature, precipitation, is not just the local effect, but also your neighbors' temperature, precipitation. Okay, so and we call this the spatial lag analysis. Let me come back. Yes, so I just want to emphasize, yes.
For either temperature or precipitation, are you looking at the mean? Or are you looking at like the top 5% of?
Yes, I will explain when I come to that. Let me, before I go to the result itself. So then self. So I want to emphasize that this type of modeling, this spatial modeling, can be applied to any type of variable of interest to you, right? It can be applied to conflict, to any social problem you can think of, your physical variables, climate ecological policies, say, for example, anything you can think of. I don't know what kind of policy, speed limits, if this state of Delaware impose policies on car speed limits, how would that affect the other counties implementing a policy? Would that have any effect? I was driving here and I read, it said, by law, you have to have wipers on your lights, on your cars. Is that right? So I don't have anything. I said, and I said, well, I don't know what the law is, but I was just thinking about it. So in other words, when a country or agreements, peace agreements, or conflicts, the conflict in this region, how will that be generated in the other regions? Spillovers effect, right? So poverty, also, the decision to leave if I am poor, of a woman of color, So where do I decide to live, right? Will everybody be attracted, and how is that will be the effect on the other countries? Will everybody just conglomerate in one region, right? This is something very important to study, I guess, for policy making. Yes, so I just want to emphasize that this is just not economics, right? So, and I have seen, this is not new literature, it's really old, right? I mean, old. So looking at this map, two maps, this is just I will present today only the United States and the South, and only precipitation, and only GDP per capita, because of time, okay?
No, this was, did you do Hawaii and Alaska or no?
No, because that would be a little bit too far away, right? So, but
But the paper does not.
the paper does not include that, and it will not include that,
But it also it'd be hard to measure because of
the distance.
because you are relying on some physical proximity.
Exactly.
Edge effects. you call it?
Yeah, I will explain how to define neighbor, because that's also, what do you mean by neighbors, right? Right, so when I see this map, and this is just the United States, so how in the world I can offer you one number for the effect of precipitation on the GDP? How is that possible, right? When it's such a heterogeneity in the region. And you can, again, you can still criticize me, what you study the South? I mean, the South is all of this, right? So actually, I'll explain. So, it's a big heterogeneity. And also precipitation here, also. I mean, the precipitation on the whole country, how is that work? How do we interpret that? So seeing that, then and reading these other papers, they give me this big number. One gave me X, the other gave me 2X. And I said, what shall we believe? And imagine the whole world, Africa, one number for the whole world, right? And there are all these variables included there. I don't understand. But anyway, so this is seeing this figure, mapping these figures is the one that made me to think you can study the whole region, right? Okay, so this is the cases that I present to you today. My south, which are what is the census called it East South Central, and the West South Central. The other south is Maryland, New Jersey, North Carolinas, and Florida. And also there was a little bit too different from the other ones. Of course, somebody can say, well, these are too different too, right? But anyway, so I concentrate on that region. And I will study, of course, also the other south, right? And I will include the other regions. Let me see, did I say which regions? No, maybe I did not. Okay, I'll come back. Oh, I was. Okay, so the other regions are the West, of course, the Midwest, very important because of agriculture, so, and I can divide the Midwest also in a couple sub-regions, right? Okay, so what is it that I do here again? I examine the effect of temperature and precipitation on GDP per capita and total GDP growth, right? How GDP is going to grow over time and how that is going to be affected by these climate patterns. So, in the case of GDP growth, I include population growth, right? Yes, so that was a little bit of the question, but so in this case, I study only the level of temperature for this version of the paper. So there are many ways to introduce temperature. It can be, is it higher than the average over the period, higher than the certain percentile, or so on, right? So what I have done, which I'm not present today, but I have the result, is how the GDP today is affected by the average temperature in the last 3 years, But this is this is a work in progress, right? But there are many ways and I'm aware of that. The other crucial thing that I don't have here in this version of the paper is extreme weather. And how do we define extreme weather? That's another issue, right? So for the moment, I have just the level of temperature and the level of precipitation, okay? So the data is, again, is resolution of different types, but of course I have put all of them working and resample them to have all of them at the same resolution, right? From different sources from ERA and this humo and this precipitations from chips. And if you have a suggestion for the data that is better than I have, I'll be happy to hear from you, okay? Okay, so I said that that I make sure that the geography is you know, compatible across the different data sets, right? So, but then I'm sure you can ask, you may be asking me or asking yourself, what if she decided to do the spatial analysis? How do we know that this is the right? Why don't she doesn't do what everybody have done? You know, forget about spatial analysis. Just study the effect of temperature on the cells, period. You know, so and of course, I can guarantee we have to do some tests that the modeling is valid, that is the correct way to do it. You know, so and just to I present just one of them to show you. So yes, let's think about this. What did this graphic says? You can see there is a positive relationship between what? This is the local county, you know, that you can think of. And these are, and here you have all the neighbors, counties. Yes, I'll come back. What do I mean by neighbor? But I just think about in whichever way you can define a neighbor. So that means that when there's a positive relationship between the local county and the neighbors counties GDP per capita, that means that when the GDP in one county goes up, that means that the GDP in your country will also go up, will go up, right? And this is the relationship 1990, and this for 2019. You can see that here is a little bit more dense. Just it seems to that the correlation has increased over time, you know. And in fact, I do show that in the statistical work here. So so this is this is some kind of one of the tests that you do to make sure that the spatial modeling is the appropriate one. You know, that it is correct to think that the GDP in your counties will affect your own county. Your neighbors will affect you, okay? So let me say, so what is it that I'm studying here? What kind of, and don't, okay. So this is the you can say that the econometric relationship, the statistical relationship that I analyze with the data, right? So what is this? How do we interpret this? So without putting some words, the only thing you need to worry about, don't worry about the notation or the math. You can say there's very little math here, but it still may sound not easy to read. But YT is the GDP per capita. I'm only concentrating on GDP per capita. So what is the GDP per capita explained by? The GDP per capita is explained by the neighbor's GDP, what we call it the GDP lag in a space. You know, that's the terminology used in the literature. Yes. So how your GDP is going to be affected by the GDP of your neighbors. And it's going to be affected by the local effects, your own temperature or precipitation, but it's going to be affected by the global effects of precipitation or temperature, right? So this is the relationship that I estimate using the data that I show you, right? So we want to estimate what are the spillovers of economic activity in your county, number one. Number two, what is the local effect of climate on your county? And number three, whether there are also spillovers, on the climate patterns of your county neighbors, right? On your own county. So this is what we do. So I will show you some estimates, and this is what we're gonna concentrate on, okay? On this lambda, what does it mean lambda? When it's positive or negative? On this beta one, when it's positive or negative, beta two, when it's positive or negative, of theta one and theta two, same thing, okay? So, again, why is the GDP per capita in the local county? We call it local county, right? Say, what's the name of the local county in
Newcastle.
Newcastle, okay, so we say, what is the effect of the GDP per capita of temperature in Newcastle? And, but do the neighbors have effect on the GDP on the Newcastle county? Okay, so let me just, since I explained this already, let me just jump over. The last one, what I wrote here is, I explained it already. Then you see this W there, right? And what is this W? We call this some special weights. And what are the special weights? Those special weights take into account, describe how the neighbors are related to the Newcastle, right? So, and the way you define the neighbors, of course, is very important because, do I consider one neighbor? Do I consider two neighbors? Do I consider a neighbor that is 100 kilometers from Newcastle? Or a neighbor that is 20 miles, 20 miles from here, or 100 miles from here, or how many, right? So, and that definition already will affect the results, of course, right? So, and this, all this methodology is inspired by Mr. Tobler, that said that everything is related to everything else, right? And but near things are more related to distant things, right? Okay, so again, these special weights describe your neighbors. How are they characterized? And of course, there are many ways to define your neighbors. So the way I decided here is there are three ways you can describe neighbors. The first one is I choose the 5 closest neighbors. Yes. The other two are, for example, the contiguity of the neighbors. You can see is we call it this the queen pattern. All the ones that are in the Newcastle surround this. And the other way to discuss is that, well, I will decide on the distance. Only the ones that are 50 miles from Newcastle, or less, 50 miles or less. 60 is not my neighbor, right? So, but for this study, for these results, I only have present the result when I choose the 5 closest neighbors, okay? And of course, once I decided this neighbor, I will have a list, right? For each county on the United States or regions, there will be 5 neighbors for each of them. That list, following some methodology, you define a weight, what that weight means that the closest neighbor will have the highest weight, there will be other neighbors as well, but they will have much less weights than the 5 ones, okay? So this is this W that I show in the equation, right? That's very important. And of course, we have to limit. We cannot say I want 1,000 neighbors, right? Or I want one neighbor. But let me just show you one graphic. What implies to choose only one neighbor? So in this geography thing, we have to choose a centroid of each county. So you can see that this is how will be the analysis if I want choosing one neighbor, right? But I'm choosing 5. So the relationship between the counties is a little bit more complex, right? So the red lines indicate the network when I choose 5 neighbors. So the analysis will be in basis of these interactions or connections or network across counties, right? So any questions? No questions?
I'm wondering why you didn't just pick adjacent neighbors.
That's
opposed to
the next revision of the paper. I can do
Yeah.
that too,
Okay.
yes. And I can-
As opposed to saying 5, because some might have 3 only that are adjacent, and some might have 6 would be adjacent.
That's right, that's right. So that's also, I have to do that to compare the results, right?
Yeah.
So yes, but and again, I can also choose the distance, right? You know, I only want 20 miles and no more, right? So so as I said that we want to explain the lambdas, which is the GDP lag in space. So how my neighbors affect my GDP or the Newcastle GDP and the local effect of climate. So let me present to you in the time that I have the result before I run out of time. First of all, lambda is, if it's not, let me know. Lambda is, I guess, is straightforward to understand, right? If lambda is positive, what it means if lambda is positive? Maybe ask them, who can tell me? What happens if lambda is positive? Well, how do you interpret that if lambda is positive? Any volunteer?
The neighbor's GDP, if your neighbor's GDP increases, yours also.
That's right. If it's negative, the opposite, right? Yeah, so that's straightforward. So what is not, if I, of course, if I omit these squares, that's what will be also straightforward, right? The beta, right? If temperature goes up, GDP will go up, right? And then the theta 1, if the temperature in my neighbor goes up, my GDP will go up, right? And so on. But when the square is a little bit more interesting, you want to, but it also has some statistical implications, but also have some economic implications and also climate implications, right? So let me explain. I need to explain what happens when beta is positive and beta 1 is positive and beta 2 is negative, and vice versa, right? So so this is beta 1 and beta 2, right? If beta is positive, I have to do this in order to make my results understandable, right? Or meaningful, better to say. So if beta is positive, so you can say, and beta 2 is negative, that means that when precipitation increases, you will experience an increase in GDP per capita. But as precipitation becomes larger and larger, you will have a decline in GDP, right? If precipitation becomes too large, then you will have a decline in GDP, right? So the opposite is here, right? If beta 1 is negative, so when you have when precipitation increases, you will have a decline in GDP. But as GDP starts to increase as precipitation increases, largely speaking, so then you will have an increase in GDP per capita, right? It sounds counteract. At the outset, I will tell you, most people, they don't include these squares. That's another issue also. They just put the linear, include a beta 1 and the regression, right? And most of the work finds a negative relationship, right? Except the mania, they also include the square. And so how do we interpret it? Becomes perhaps a little bit, you can say, how can GDP start to increase when you have large precipitation? So I don't have I cannot, because I'm not including in the result that one can interpret that as an effect of adaptation, right? Because if you adapt to precipitation, then you start to have increases in GDP per capita, right? So So, so this is more or less what I could say, what it means to have be positive or be one beta one positive or beta one negative, right? This is the way we interpret that, and of course this is perhaps a little bit more straightforward to understand because if you have precipitation, you benefit from rain, right, and water. But if precipitation becomes too large, then you will have a decline in GDP, right? So let me go to show you some results here. First of all, on the spillovers of GDP, you know, geographically, spatially, better to say. So for the whole United States, I find that land is positive. For the South and the US is positive, right? And it needs that dimension. But for the South is larger, right? So we can say it has what was your name again?
Arthi,
But excuse me?
Arthi,
Arthi says, you know, she already indicated that if lambda is positive, then your neighbor's GDP will have a positive effect on your own GDP, right? So, and that's what we find here. But and I'm very looking forward to find out what's going to happen with the other regions, right? Especially the Midwest. You know, is it larger, smaller, in the middle, or maybe not significant at all? You know, it doesn't have to be significant, statistically significant. So one thing is that land is not constant across time and across regions, right? So now we'll show you by decades also varies, right? But it will vary across regions, it will. Okay, so let's go to the beta issue here. This is the average beta 1 and beta 2 for the whole United States and for the South. Yes, remember that the data is at the county level and is this resolution of 9 kilometers. Okay, so for the United States, we find that the beta is negative, right? And for the South is negative as well, right? So that means that an initial increase of 500 millimeters of rain, it will decrease the GDP per capita by 125, right? These are the numbers for the United States. I'll show you for the South now. So, but has precipitation started to increase, you know? So then you will have a reverse and development of the GDP per capita, and the GDP will start to increase, right? And I suppose you have this convex, we call it, go this way and then goes up again, right? And again, the way I interpret that, even though I don't have a statistical proof to you, that the way I can interpret is that there must have been some adaptation and mitigation policies, you know, to be able to increase the GDP per capita again. So, okay, so this is for the whole period, right? And what about for 1 decade? For 1 decade, then the beta 1 now is positive, you know, and for both of them, for the US and the South, right? And for beta, it's negative. So again, we have this issue that, okay, in that decade, in that region, or the United States benefit from precipitation. So GDP start to increase. But as precipitation start to increase, then you see a downturn in the GDP per capita to decrease, right? So, but the effects are different across decades, and I'll show you in a minute, okay? So it's not constant effects, right? Let me just show you. This is the way I can illustrate, and not all this is statistically significant. You know? The statistical analysis give me this. I just show you graphically, so not to fill out with numbers, right? But translating all the statistical significant, and it give me the following. This is the one I just showed you, right? The beta one has an effect of plus 685. The first initial precipitation, but as precipitation starts to increase, there will be a decrease in GDP, right? And let me go back a little bit. I just wanted you to notice something here. This is almost more than twice, for the South, is more than twice that for the United States, right? So, which is not strange in the South are affected by all this hurricane and all these problems, right? Okay. So what I find is for this decade, maybe I can ask you, the students, perhaps, or the faculty also. When I say that for the decade 1990, the relationship between GDP per capita and precipitation is of this form. So what is the sign for beta 1 and what is the sign for beta 2? For having,
I already answered your question.
Yeah, I asked the question. Wasn't that with the negative, positive?
yeah, so in this case we have, okay, maybe, in this case, we have this shape because the precipitation increases first, then it starts decreasing because beta 2 is negative, right? The bigger the precipitation starts to have a decline in GDP, right? So what do you think is the sign in here and in the last decade of beta 1 say?
So that was the negative, positive. Beta 1 is negative.
That's right. So beta 1 is negative, right? In both cases. But then the beta 2 is positive. That means that as time went and precipitation started to increase very drastically, then you have seen an increase in GDP, right? So, and you may want to ask, and when in each of the decades, which level of precipitation made a turn, made the GDP to make a turn, right? Because you also have to, I also have to tell you that, right? So the data tells me that, oh yeah, I have it here. Yeah, yes, I'm sorry, I have it here. So the estimates and the data, of course, tells me that that turn occurred when the precipitation was 1,600 millimeters per year, right? The turn took place when the precipitation was 1,900 per year. And here when it was 2,300, you know? And if you see the data, I didn't want to overwhelm with so many numbers. In fact, it was more wet in this decade than in the others. Much more wet. Much less wet here, right? So this is what, and it's a little bit interesting because you have a downturn and they start to increase and in fact increase, right? And start to decrease and start to decrease and start to increase. So I don't know when the next turn is gonna be occurring, right?
There was a question from Kevin in the chat, our state climatologist.
Oh, yes,
Which-
please.
I'll just check that here. He's saying, okay. I don't know many locations that receive that much precipitation. He says that seems like very high.
Oh, well, I have the data.
91 inches.
No, this is in millimeters now.
Yeah, but
But
that
91 inches is equal to what?
2,300 millimeters.
Yes,
It equals 91 inches. It says.
Yeah.
Here we get about 1,200 millimeters a year.
yes, but I can show you, I don't have the data, but in this region, in the south, there was that much already. I can send it to Kevin.
Kevin, they're saying, Gabriela says in the south you have that.
Yes, and the
Maybe
data
you
is for
don't.
church, right?
Florida. Florida maybe, or
Yeah, no, because
Louisiana.
I cannot, just, I didn't bring my hard drive, but,
Okay, no, that's.
yeah,
great.
but, I can send the data to, over a screenshot Because I was also very surprised about
But what
that.
that is showing is then that there was some level of adaptation that happened after 2010. So that's why
It might have been,
the
yes, well, we don't know when that happened, right? The data said that this is for this decade. But
Yeah.
when it had happened, I cannot,
and
I can find, yes, no. I have to do this by year, so I cannot tell you when exactly, but I can tell you the level.
Yeah.
Right, so, but to Kevin, I can, screenshot, which account that is so much.
Yeah, no, he's put something else there. What does he think?
Yeah, but that's the normal, right? What do you mean by normal? You know,
Yeah.
so that is an issue, right? So that's what this work is, it was a normal, they did the average, right? The average for the whole year.
Well,
right?
actually, it's a 30-year normal, so take the average of the 30 years.
It's been 30 years, over
30
30
years,
years.
yeah, but you know, I mean, the precipitation in these 30 years is very different, you know? I can actually, let's see if I can,
One of the ways that they, in climate that we use are things called anomalies, so we look at the change from the normal to give you whether you're wetter or drier than what's going on around you.
Yeah,
let's
This
see,
is how we look at sea surface temperatures over time.
I hope I have it here,
Kevin, feel free to unmute and speak also. It'll be easier.
yeah.
Sorry, I just was letting you know I have to go to a meeting that I already planned for 12:30. So
Okay.
thanks for the talk, Gabriela. I'll follow up with you.
Yeah,
I
okay,
think
okay,
this
yes,
is
I'm
a
sorry, I
good,
can,
avenue
can I
for you
share also
to
this, no, I can share,
collaborate
I'm
with
sorry.
the climate
I
people.
should have, maybe I can, copy this, one second.
One thing to note also is just recently there was a big redaction of a study, a retraction, not retract. But it was about the environmental impact of climate, the economic impact of climate change. It was in Nature, I think. They had to call it back because the data was misleading. They had overestimated the economic impact of
Yeah,
climate change. You saw that one? It was,
Yes.
yeah,
yes.
it was just like a very big study. It had already got
Yeah.
like 1,000 citations.
Yeah, this is, you know, this, you have these huge numbers, and,
Yeah.
and you know, I ask, so, so, you know, what do we do when it rains? We take an umbrella, right? So the economy, we humans do something about it, right? Hopefully.
Yeah.
Maybe we don't have enough resources to do what we need to do. But you cannot say that the GDP per capita is gonna decrease forever, right? I mean, that's makes no sense to me, right? And that's the point of having, you can say, you know, in a modeling, what do you want to have this square? Because you want to take into account whether there is a decline, you know, whether there is really a reversing of the effect, right? You cannot say, well, when temperature goes up, GDP goes up. Until when? Right? And for how much? You know, does it matter the level of precipitation temperature? Or does it matter? It's always go up no matter what. You know, so that's the purpose of including this square, right? But also from the point of view, statistical point of view, we call it this in statistics an explosive series. You can't have something that explodes forever, right?
From the, no, but just with that nature study that was quotes et al. From the Potsdam
What else
Institute.
again?
Maximilian quotes from.
Exactly,
From
exactly.
Potsdam Institute, and the reason for the retraction was, it
Yes.
was Nature.
Exactly.
And they said the authors retracted this because they found out that removal of one country, it was a global study,
Yes.
Uzbekistan, completely changed
The whole
the
thing.
findings
Yes.
for the period 95 to 99. So
Yeah.
so they are now going to be reanalyzed. They
Yeah,
haven't-
is that 24 version or the 22?
This is the one, yeah, it was published in 2024 and then it
Exactly.
was retracted in
Exactly.
2025. 1 year
Exactly.
later, they retracted
Exactly.
it. By then, it had all these citations and
Yes.
all the climate activists were using it.
Yeah.
But then they were like.
Yes, yes, exactly, so this very, and you see that usually, I like to have a relationship that is simple to understand, but these people, you read the paper, they have the mean of the last quarter and plus relation to whichever region, whichever
Yeah.
year, and they say, but what did you get? And I have problem with the articles in Nature, because it's, where are the numbers? In economics, we have to show the tables.
Yeah.
You can't just put it in the appendix, you have to show, you have to demonstrate that this is really significant. And you have to say, how did you get this variable with x minus 2? Okay, I know that it's x minus 2. You cannot say a minus 2 plus z and plus y and plus v, plus whatever. And I don't know where z come from, theta
Yeah.
come from. We are, it's very strict,
Yeah, no, definitely so publishing. We
Yes.
should try to
Try to
give some
finish
time
that. I
for
think I
discussion.
finished. I
No,
fin-
that's good. But I think this is
So
great.
I
that it's-
only have 2 slides.
Yep.
The slide is about is about this the special effects of your neighbor temperature.
Mm.
Yeah, in this case, precipitation, right? So these are the effects that for the south. So these are what we call it the global effects, right? So this is the effect of precipitation on the local county, right? So theta is the same interpretation, right? Of either in this way that we call it convex or in this way, right? So when it's negative, that means that this is this way, right? So that means that the precipitation will cause a decrease in your GDP in a local county, but eventually when it becomes large, it will start to increase, right? So the conclusion here is that, of course, your neighbors affect your GDP, the weather, the climate. But hopefully there are some mitigation effects here, right? But I will have to be careful because my local effects can be exacerbated by the neighbor's weather, right? The climate. Okay, so, and this is the difference across decades for these special analysis or spillovers. In the South, I didn't find statistical significance for the United States. No spillovers, but that's not strange because we study the whole United States, right? So what do you mean by local? What is that, right? In the South, there are no spillovers, at least statistical significance, for the first decade. But for the second decade, 2009, 2000 to 2009, 2010, 2019, then the spillovers are also very similar to these ones. Yes, it's a negative theta 1 and positive theta. Okay, so let's see.
Also, like if you are looking at it in the south, is it like the coastal counties and how they are more likely to have spillover compared to the ones further from the coast? Because a lot of the impacts of climate change are more coastal.
Probably, yes. That's another thing that but that will be also including the oceans, ocean phenomena. I don't know, right? So,
Yeah.
but let me just conclude by writing the conclusion. So we have found out there are global. Excuse me, did I make this right? Yes, yes. There are global spillovers on GDP, right? So your neighbors affect your county. And then and both global and local spillovers in the south, right? At the regional level, right? For the United States, I'm not worried there are not effects because it's how can I talk about the whole United States spillovers? So and what is the further work? As I mentioned, the other regions include extreme weather patterns or climate patterns. 5 other explanatory variables, because even though these people don't include any of the variables, but which variables can I find that can also explain GDP per capita? You know, in the regular analysis, if you have a national GDP, of course you have national education, you have capital investment, you have banking variables and so on, right? But when you study at a special analysis, then I have to find such a level of disaggregation, right? And that's a challenge, right? So, but anyway, I'll try. So consider forecast of kind of variables, right? And also some analysis at the cell level. I don't know if I can do that, but anyway. So these are more or less what I am, but there are the things that I'm interested in working also myself, right? So,
I think this is for Dr. Wu's lab, Yao, you have interacted with Yao, because
Yeah.
he does work with water, geospatial and climate, and it might be a good interface for you to connect with them.
yeah, yeah,
Two of his students, I guess,
yeah.
no?
Yeah, so all this is on water, right? So if you have problems in the, I guess there you have done also water issues, right? So
Yeah,
what
I
is,
think comments help if after.
Yeah, no, and plus on the geospatial side also, Aarti and her team, by the Kyle Davis, they work a lot with the whole range of geospatial data.
yeah,
So it
yeah,
might
yeah.
be helpful for
Yeah.
you to.
Well, I'm a word that I will try to do also, hopefully I don't know about that. Anyway, this type of analysis for the chain, the food chain,
Yeah, yeah,
you know? So when the food chain is interrupted in this region, how is that affecting the other regions? Right? And what is the effect of that on all the chain of the food production?
yeah,
And you can think of, transportation,
yeah.
intermediate production, and so this is more or less my last
The
issue, you
supply
have that,
chain of-
yeah, supply, the chain effect, and do that especially, right? So,
Mm.
yeah, for me, it has been a very awakening methodology, right? And it's I've been used a lot by geographers, and so it has been very fascinating for me to start this work, right? So anyway, but
Great.
thank you
Thank
for
you very much,
for-
Gabriela. Yeah. Any other?
Gabriela, one thing I'd say, just think, we can talk more about it another time, but.
Yeah.
I know how are you defining precipitation? That's number one, and the type of precip really matters. Now, obviously, the south, you're talking about rain, but in the whole United States, it could be rain, it could be snow, it could be hail, it could be
Yeah.
basically glazed precipitation. All of those things will make a difference probably with respect to what you're finding. So I think precipitation type is something you want to be clear about.
Yeah,
What exactly you mean, and then if there are data, and I know there are data on precipitation type, and that gets to extreme events, I'm thinking, okay, this agriculture crop in Florida, a hailstorm blows through, I've lost a lot of money there because the hail has ruined the crop for the entire year. So the type and
Type is really.
timing, I think, is really important. And then with respect to, you had just precipitation of a time for the decades. Again, extremes are important, but I'm also thinking the intensity is more important. So how many millimeters per hour did you get? That may be more important than the just total, the magnitude of the rainfall over time. For a lot of what you're doing too.
Yeah, yeah, absolutely, I think, and, yeah,
but there is data for type of precipitation.
yeah, yeah.
Oh, yeah.
At
Sure, yeah.
such a high resolution.
Definitely, yeah,
Yeah, I'm sure.
yeah.
Oh, really?
Counting
Because
that-
I have a lot of, I called your climatologist, and I was having like a 0.1 resolution, and Kevin, I should talk to him because, and to
Yeah.
Shai, and he said, oh, there is no such a
Kevin can
data.
help you
There
with
is
that.
such a data, I said, because I cannot aggregate GDP, because you can say, well, why don't you use 1 degree, right, and aggregate that GDP? But then I lost a lot of information. So I need to have, to get GDPs at such a resolution is an enormous.
That's, but you can get definitely weather data, you have very high resolution.
Yeah, and now they found, the one I found is chips, but there was just precipitation. So I wasn't able to find, I really struggle. Temperature, well, that was a little bit better, but for example, for temperature era, They look data for San Francisco.
And then it's rarer, but if you really want to get crop loss, or you can look at soil temperatures too. I mean, I'm assuming you mean air temperatures, when you talk about temperature, but soil temperatures also.
Yeah,
This is ambient air
that's what
temperature.
but that would be very crucial for the West, right?
Well,
Midwest.
also the permafrost melting, you know, in
Yeah.
the, if you were doing up in Montana and that area. you know,
Yeah.
Then it,
Yeah.
altitude makes a
Yeah.
difference, so it's a
Yeah.
lot of,
I was
in the
looking for it-
Rockies.
Yeah, I
Anyway,
have
if you're
that,
just starting, obviously, it's
But this
really
is a-
interesting, but.
it's a very, I think, it's a topic which has a lot of opportunity for collaboration here. Because
Yeah,
there are
yeah.
people who have expertise.
yeah, I
in-
took a little bit with the climatology.
Yeah, I
and
think talk to
hopefully.
Kevin, talk to Kyle, and also Kelsey.
Yes,
Malloy
I had to
as well.
Kelsey, you
Yeah,
know, so
but
hopefully we
also-
can get some
Yeah.
support, financial support, right? So-
Yeah, maybe, yeah, good. So I think it's a good prospect for a grant,
Yeah, so this work
This
and
could
then,
be,
so for example, and also to introduce artificial intelligence, I talked to Kelsey, you know? But I haven't thought about honestly about this type of precipitation because I get precipitation, I struggle so much and I said, I cannot ambitious so much to get type, you know, so, but that's good that you tell me that. But do you have the source? Because
I don't, that, usually I collect my own data, so I have 5-minute data resolution, or 2-minute every data, what's going
did you
on
collect the data?
for myself, but not as far as the entire country.
yeah.
Oh, I
But
see.
there are data sets, I'm sure we could get hourly
You
data
sure?
on precip and everything else. You could easily collect, you could easily get at precipitation intensities and all that very easily.
Actually, we have hourly precipitation and temperature gauge
Exactly.
stations
Yeah,
over the world.
Yeah.
And actually, our group is now working on the downscaling from higher resolution data to lower resolution data to higher resolution data in the Great Lakes region.
Oh,
And you
Yeah.
can find the source of.
Yeah,
this
and that's also to go to high, that's, I was a little bit concerned to do that exercise of going from, you mean from, say, 1 degree to 0.1 degree?